This is my 4th year at the Craft Conference, and I've introduced, I don't know, maybe 50 or 60 speakers. This is, I think, my favorite bio that I've ever had the opportunity to read. Eli has been in tech since being released back into the wild from studying maths at university 7 years ago. They've spent their time working in industries ranging from telecoms to biotech to analog circuit design, continually getting nerd-sniped along the way. These days, they're a freelancer who speaks at conferences, runs workshops, and learns whatever they want. In their spare time, they like to play video games, knit and sew, and hang out with their cat. The title of our talk is Language Games. Please put your hands together for Eli Holderness.
Jó reggelt, Budapest. My name is Eli, and I am here today to talk to you about how we talk to each other. So, what this talk is about. Has anyone ever been in a meeting and, 15, 30 minutes in the meeting, you realize that you and the person that you're talking to are talking about completely different things? Has anyone ever experienced that? I see some hands, yeah. Or have you ever been in a software team building a product, and your product manager comes to you with a requirement that makes sense for the real world? Let's say it's that you're building an e-commerce project, and the product manager says, we need to be able to refund users in a different currency than the one they paid in. That's not an unreasonable thing to want. But the way that your system is built means that you'd have to tear down the whole payment system and redo your data model. Does that sound familiar to anyone? Yeah, again, a couple of hands. This talk is about how these kind of problems arise, where do they come from in terms of how we communicate with each other, and what we can do to try and avoid them. So I'm going to take you on a bit of a journey through philosophy, linguistics, and hopefully by the end of it you'll have a bit of a better idea about how we can talk to each other and be understood. So to start with, I'd like to show you my model of what I think is going on when we talk to each other. There's me and there's you, and I have an idea in my head. And as a result of this idea that I have in my head, I say or do something to communicate it. I make noise, I make language, or I write something down, or I make some kind of gesture to communicate this idea. And as a result of this action that I've taken, you perceive something. You hear sounds, you read words, you see gestures. And this causes an idea to arise in your head. This is what happens when we communicate, right? And of course, it can get more complicated because in the middle of that, we might transmit that sound over the internet, or those words, or those gestures might be communicated over video, or all kinds of things like that. But we're not going to worry about that complexity too much. We're going to focus on this model here, where you have 4 stages. Idea in my head, thing that I say, thing that you hear, thing that you think. And those are 4 different things. And what I'd like to focus on particularly is the fact that we have these translation layers here in between my thoughts and my words, and between what you perceive and your thoughts. And we can never actually understand what's going on when we translate these things. So the nebulous ideas that I have in my head and the words that I use to express them, they're not the same thing. We have 2 separate concepts going on here. We have the idea, and we have the expression of the idea. And so when I was putting this talk together, I actually talked to my spouse, who is a really keen linguist, and said, I think I want to write this talk about the nature of communication and what's going on when we use language. And they said, okay, well, the first philosopher that you've got to read up on is Ferdinand de Saussure. And this guy he was a big deal in 20th century linguistics. And the reason we care about him today is that he was one of the 2 founders of a field that's now known as semiotics. He called it semiology, which I quite like as a name. It's become semiotics. And the key idea that Saussure had, which was groundbreaking for the time, was that we have these 2 concepts, essentially. We have these two units, these 2 sort of pieces of machinery when we communicate. We have the thing that we're trying to communicate, which he called the thing being signified. And we have the thing that we try to do to communicate that concept, which he called the signifier. Now, I'm going to trip over my words if I try and say signified a lot, so I'm going to actually change that word. I'm going to say concept. You have a concept, and you have the thing that you do to signify those concepts. So, for example, this animal, in Egyptian, is called a mao, and we can understand why, right? That's a sound that makes a lot of sense to be associated with this concept. But in English, it's cat, right? In Hungarian, mačka. These aren't sounds that intrinsically have anything to do with the concept of this animal, right? And this was what Saussure's big statement was, which was radical for the time. The concepts in our heads and the things we use to signify them don't intrinsically have anything to do with each other. The mainstream understanding at the time was that there was some kind of intrinsic link between concepts and the sounds we make in order to signify them. And Saussure said this isn't necessarily true. So, we've got this idea that we've got concepts in our heads, things we do in order to communicate them, things that are perceived as a result of that communication, and the ideas that arise in the heads of the listeners. And with the ideas of Saussure from semiotics, we can understand that between the concept and the signifier, there's some sort of translation going on, right? In this layer, there's some sort of translation. And that the ideas that happen in my head and the idea that happen in your head, we're never going to be able to directly compare them. It's apples and oranges. I can't see inside your head, you can't see inside mine. All we can do is exchange these signifiers. So, given that these two things are not, we can't actually directly compare them, how can we know that we're communicating efficiently, correctly, usefully, meaningfully? How can we understand this relationship between concepts in our heads and the ways that we try and communicate them? Well, Saussure has ideas about this too. What Saussure said was that this is what's happening when we use and communicate using language. You have an idea in your head, and you do something in order to communicate that idea. And he called this act parole, like an act of speech, an act of communication. And the only way that you can understand how these two things are linked is if you have some kind of concept of external language, which he called the langue. And together, langue and parole make up language. And the langue is what you learn as a child. It's how you learn, the langue is the idea of English as a concept, or Magyar as a concept. And it's something which exists independent of any one person, but could not exist without people, right? It's this thing that we create collaboratively, and it's what linguists study when they study language. They're studying this idea of this sort of collectively created, collectively understood, but entirely constructed language. And what Saussure said, which was again radical for his time, was that acts of parole, speech, actually inform the langue. And we know this, right, because that's what slang is. We make up jargon all the time in our careers, right? The idea that, I don't know, I'm thinking of memes in particular. The idea that, has anyone seen the meme of Kermit the Frog drinking tea? And it means somebody that I don't like is having a bad time, but I don't want to be bitchy about it, but I'm kind of being bitchy about it. And that's become part of the langue. I can show you that image and you might understand what that means. Or, just slang, like saying cool. Cool doesn't necessarily refer to temperature, it means cool. But it didn't always mean that. It gained that meaning through repeated acts of parole, speech. So these three things form a circuit. We understand the langue, we use it, and our usage then informs the language, the langue, back. And this is called Saussure's speech circuit. So we have this idea of some external idea of language that is shared between people, independent of any one person, but can't exist without them. So how can we understand this? This is what we need to understand in order to improve our methods of communication with people. The better we're able to adhere to this nebulous idea of the langue, the better we're able to articulate concepts through signifiers. And this is where we meet our second philosopher of the day. And he is one of, I think, the most famous philosophers of all time, Wittgenstein. And he was a polymath. He did everything: logic, maths, language. He had something to say about pretty much everything. I really love his work. And the thing we care about today is that he came up with the idea of language games, for which this talk is named. So his idea was that, much like games of chance or skill or athleticism, when we use language, we are playing a game. And that game has rules, and you make moves that follow or do not follow the rules of language. And he usually articulated this concept of a language game through analogy, so I'll do the same. Let's imagine that we have two software engineers, let's call them Peter and Claudia, and they are building some Lego together. And they have a Lego set that is comprised of these three different pieces. And what's happening is that Peter is building the Lego, and Claudia is handing him pieces of Lego. And Peter says, block. And Claudia hands him one of these pieces. Then Peter says, plate. And Claudia hands him one of these pieces. Then Peter says, jumper. And Claudia hands him one of these pieces. They're playing a language game with very limited rules in which those words correspond to, please give me one and exactly one of the kind of Lego piece that corresponds to that name. Now, it's worth noting that this language game is actually inefficient because jumper, block, and plate, between them have 4 syllables in total. They could have used the colors, pink, white, blue. That's only 3 syllables. But they're Lego nerds, and they like using the official Lego terminology for these kinds of blocks. So language games aren't always efficient. They're informed by human desires, needs, emotions. And what Wittgenstein was saying is that all language operates like this. There are rules that we have to follow in order to be understood. We're building up these complex systems of rules and ways that we can communicate abiding by those rules. So if there are rules to language, what does it look like when we break them? What does this sentence mean? It doesn't mean anything, right? This is what's called a comparative illusion. It scans like perfectly reasonable English, but it doesn't actually mean anything because the things being compared in the sentence can't be compared. More people have been to Berlin than I have. Well, more people than I have been to Berlin, or, it doesn't mean anything. So this is an example of breaking the rules of language, a sentence that doesn't communicate anything. However, there's a difference between breaking rules and playing by house rules, playing by rules that are specific to you. So here's another sentence. Does anybody know what this sentence means? This is something that I say, my spouse and my housemates and I say frequently in our household. Does it help you to know that we have a cat? This means we have to trim the cat's claws. The cat is the baby. Sometimes she gets sharp. We need to make her less sharp. That's unsharpening. We need to unsharpen the baby. So that's what that sentence means. In a particular context, this has meaning. We play with house rules that modify the standard rules of English. And this was the big thing that Wittgenstein said with his concept of language games, which is that context sets the rules. Different words, different signifiers in different contexts can relate to different concepts. We're not talking about a human baby that we need to unsharpen. We're talking about my cat. She's nearly 12 years old. Even if she was a human, she wouldn't be a baby, but she's the baby. She's our baby, because that's the context of my household. And this, again, like Saussure saying that signifiers and concepts did not have any intrinsic relationship, I think Wittgenstein is saying a very similar thing here, and it was, again, radical for the time. The way we use language has different meaning depending on the context in which we use it. Does anyone recognize this phrase? Yep, a couple. So this is part of a series of messages designed by the Institute for Long-Term Nuclear Waste Storage. So we as humanity, we've created a problem for ourselves, which is that we discovered nuclear power. And nuclear waste of the kind that we currently produce has a lifespan on the orders of tens of thousands of years. It will continue to be dangerous for that long. This is longer than any one human civilization has lasted, any one language in particular. So we now, today, have a need to communicate to people in the future that there's dangerous stuff buried here, don't dig it up, right? But we have no idea what their language will look like in 10,000 years. We have no idea what their cultures and their civilizations will look like in 10,000 years. And this is a pretty complex concept to try and communicate. There's nuclear waste here, don't dig it up. And that's without accounting for the fact that if you tell human beings not to do something, what do? They do the thing. So this institution has a mandate to try and figure out a way to communicate this concept for the safety of future people. And they came up with this series of messages ranging from very, not vague exactly, but broad, something like this, to more and more specific, that, there is dangerous here, the danger is present in your time as it was in ours, the danger is to the body, just like incredibly metal, like series of words, so cool. And one of the other things that they developed was this, which is ISO 21482-2007, and this is a sign. This is a symbol meant to communicate, nuclear radiation is here, you should leave. And if we actually think about what we know about the context of future people, which is very little, we can understand how they constructed this. So first, we have a skull. We don't generally see skulls in our daily lives unless something has gone horribly, horribly wrong, right? As a species, we have tended to bury our dead, even from a very early time in our known history. We don't tend to see skulls. Skulls is bad. Skulls means something is very badly wrong. And we can assume that this will be a meaning taken from this symbol, even in the future. Next, we have a person running away. And we can assume that within tens of thousands of years, the body map of humans will likely not have changed. Obviously, you have humans with limb differences and so forth, but that will probably be understood as a person in motion, we can hope, given the context, the limited context we have of humans in 10,000 years. And next, we have this symbol. And this is the attempt to convey nuclear radiation, which is a very specific concept that does not have many ways to relate it to things that we think will be likely to stay unchanged, such as the shape of the human body. So we've got the nuclear radiation symbol, and we've got rays emanating from it. And I think this is the weakest part of this attempt at communication, but for good reason, because the idea of nuclear radiation relies on a lot of shared context and understanding of physics. And it's not perfect. I think I can understand where each component of this came from, and I think it makes sense, given what we understand about how communication works. But as my friend Dylan pointed out, it could also mean when snakes come out of the ceiling fan, pirates are going to come, so run away. We can never actually know what somebody will take from our acts of speech. We have to be able to assume that we're playing a language game with the same rules, and it's very hard to know that. So, we've understood now what happens when humans talk to each other, try and communicate with each other. But we're software programmers. We don't have to do any of that. We want to talk to computers, right? And when you talk to a computer, you have an idea in your head, and you write some code, and then the computer takes it and it does things with it. And a computer doesn't have interiority in the same way, right? It doesn't have an idea that's being created. It takes code, it compiles it, it runs it, it executes it, and it does something. And you get feedback from the computer in a way that you don't from a person. You understand what the computer is doing in a way that you can never understand what another person is thinking. And this is very cool. And when we think about language games and computing, it's easy to say a programming language is a set of rules for a language game. And I think this is true. You teach the computer what it means when you say if, open curly brackets, or what it means when you say break, or you define a class. But I think that you can go further than this. I think that once you write software in a given programming language, you're defining further rules. House rules, like when I say I can unsharpen the baby. When you define the name of a custom class, a function, you're adding rules to the language game that you're playing with the computer so that you can articulate more specific concepts and not have to, reinvent the wheel every single time you want to tell the computer what a user is, for example. So when we write software, we're building up a very complex language game that we're playing with the computer in order to communicate to it that we want something particular to happen. So we come back to this model where we have the programmer and an idea in their head, and they build up rules to a language game with the computer by writing software. And the bit where the computer takes code and understands it and interprets it and compiles it and executes it, we can understand this pretty much entirely. If I write some Python code, I know it's running in CPython, I can understand what C code is being run, I can look at what that's actually being compiled to in terms of machine code. This is a solved problem, pretty much. I mean, we're developing new programming languages, but broadly they are for developer experience and not for the ability to actually execute novel things on a computer, quantum computing aside. And this half of the diagram is also getting close to being a solved problem. This part is just get good at code, understand the language that you're writing. This is also getting to be a solved problem. And a bit of a side note, I think that when you introduce a large language model or machine learning, any kind of applied statistics into this side of the diagram, that changes the equation qualitatively. Because if I've now got something that I can't go, oh, well, I know what this is compiling to, and I know all the operations that this machine is going through, and I can actually inspect them, this half of the diagram becomes inscrutable again, which I think is really interesting and a bit scary. So we have this paradigm where I write code and the computer runs it, and everything's perfect, right? Does anyone feel that their life as a programmer is perfect? Because this model is not correct. What's actually happening when we write software is there's me, and I'm writing code, and I'm committing it to GitHub. And there's my coworker on my team, who's also doing the same thing. And you may note that, does this light work? Is this light? No, it's not going to show. The pink light bulb, the blue light bulb, not the same thing, right? We can never know that we've got the same ideas in our head about what it is we're trying to build. And when we write code collaboratively, this is one of the ways that we communicate those ideas, is through writing code and saying, this is what I think the computer should be doing, because that's what code is this is what I think the computer should be doing. But we also have out-of-band ways to communicate with each other, things like meetings and documentation and notes on our pull request. So how can we understand communication in a way that's going to help us make this process easier? When we build software together, we're using code to communicate, and Ian gave a great talk about TDD yesterday in which he touched on this, the idea that tests in particular are communicating about the desired behavior of software. But we also have other means to communicate, things like code comments. And this is where I want to bring in our third and final philosopher of the day. This is Paul Grice. He was a British philosopher of language, and the work that he did that we care about today is his theory of the cooperative principle, otherwise better known as Grice's maxims. So Grice observed instances of cooperative communication, and what he meant by that was communication where we're in good faith trying to exchange concepts and come to an agreement. It doesn't include things like jokes or lying or anything that is not an earnest and direct attempt to exchange concepts. And these are often stated as imperative things, as prescriptions, like things that you should be doing, but they actually arose as descriptive ideas, things that he observed when observing and trying to sort of do some kind of taxonomy to these kinds of communication. So the first one is the maxim of quantity. When people are communicating cooperatively, they should be as informative as required, but not more. You don't want to info dump if somebody's asked for a quick summary, but you don't want to leave information out. This is pretty intuitive. He also set forth something that he called the maxim of truth. Only say things you know or can reasonably believe to be true. This is why lying is not, obviously lying is not included within cooperative communication because it violates this rule. And this is also why telling jokes, for example, doesn't fall under this, because often jokes involve some kind of misleading in order to subvert an expectation and make people laugh. You also have the maxim of relevance. If somebody asks you, oh, does it look like that? Oh, what color is that train or something? You don't tell them the entire history of the paint and the minerals from which it's sourced or something. Even if you know it, even if you think it's really, really cool, this is something I struggle with. So this is the phenomenon where, if you're trying to communicate about a topic, you need to stay on topic. And you need to not go off on tangents if you are trying to efficiently and in good faith communicate concepts. And the last one is the maxim of clarity, which I really love. And what this means is that you need to avoid ambiguous language or obscure language. And this is something that I really like. There's a Wikipedia called the Plain English Wikipedia, which is often Wikipedia is quite verbose. It uses, this is something I try and pay attention to in my talks and don't often succeed, is using dictionary words when simpler words will do. You need to avoid, or try to avoid, the possibility that the language you use is not going to mean to the other person what it means to you, either because they don't know that word or because it's ambiguous, right? And I love the maxim of clarity because, so he had prescriptive names for each of these. So maxim of quantity, be informative. The maxim of truth, be truthful. The maxim of relevance, be relevant. And for the maxim of clarity, which is all about using clear language that is not going to confuse the person to whom you're speaking, he used the word be perspicuous. Has anyone ever heard that word before? Perspicuous. I'm aware that not everyone here is an English first language speaker. I am. I had not heard this word before I went and did the research for this talk. Be perspicuous. And apparently what it means is pretty much what he's saying with the maxim of clarity. And these are all well and good, but the reason I bring them up is because they relate to how we can write code together, right? Because what code is an attempt to communicate concepts with each other and with the computer about what we want to happen. So, what about code? Each of these four maxims can correspond to various sort of ideas about maxim of quantity is sort of about clean code, make sure that you're actually passing through all the information you need in a function. Maxim of truth, check your assertions, make sure that your model that you have of what you think reality is going on is actually valid. Maxim of relevance, splitting code up so that it's, you've got single functions that deal with only one thing and you're not doing lots of things that aren't related to each other in a single place. These are all clean code concepts that are well understood, sometimes practiced, but none of it's groundbreaking. But the one that I think is really interesting is the maxim of clarity. It's about using the correct language for the job, about using clear language that actually is well fitted. The signifiers you're using are close to the concepts that you're trying to define and are well understood by everybody to have that relationship between signifier and concept. And when we're in a software team, I've said that this is the model of what's happening when we build software, but I've lied to you again. Because if we were just all building software in our software teams, things would be a lot easier. We're getting towards this being something of a solved problem. We know how to talk to other software engineers about code. We've just been doing it for the last day and a half. But it's actually more complicated than this, because what's really going on when we write code is that we have stakeholders who pay our bills and our cloud computing costs. And they have an idea in their head of what they want to happen. And they communicate it to us with requirements, customer requirements. Your product manager says, oh, we need it to do this. And you perceive that. And you, as a developer, your job is to then go and try and plumb that idea all the way through to the computer. Right? Your job is to try and understand what is in your stakeholders' heads and to then try and translate it to what the computer does. And the less work we can do as part of, in the process of doing that job, the easier our lives will be. And the reason that I say this is, this is really important because what stakeholders think is going on when we write software is this. Stakeholders have an idea in their head, and they talk to the computer, and the computer does it. and we are just an implementation detail along that way. Our job is to take their ideas and make the computer do it, and then we all get paid. So as a translation layer, our job is to do as little work as possible so that we can have more time to play Baldur's Gate 3 or whatever. And in order to spend as little time doing this and as little effort, what we'd like to do is define the rules of our language game that we play with a computer to be ones that can also be understood by the stakeholder, so that we don't actually have to do a load of translation. When the stakeholder says user, it matches what the computer thinks of as user, right? And this is what domain-driven design is. We're defining the rules of our language game, which is the software that we write, so that it's comprehensible to the people whose ideas we are trying to communicate, which is our stakeholders. We are just an implementation detail. And yeah, this is domain-driven design. This is the sort of, I didn't know this is where this talk was going when I wrote it, and I didn't actually know a lot about domain-driven design before I did. I sat down to write a talk about communication, and this sort of fell out, and I messaged my friends, and I said, hey, isn't this what DDD is? And they went, oh my God. But it turns out that thinking about communication rigorously does lead to the conclusion that if we're going to try and communicate concepts to our computer so that it can do work on real-world problems, the better we're able to match those real-world problems to what our computer thinks of as reality, the way that we communicate with our computer, which is playing a language game built up by rules that we've defined by building software, defining words that live within our programming language. The better that we are able to do that and have concepts that our computer understands that are also comprehensible to the people whose ideas we are trying to communicate, the easier our jobs will be. And this avoids situations like, oh, we need to refund the user in a different currency than the one they paid in. Because if your computer understands what user and currency and refund are in the same way that your stakeholders do, and your stakeholders' comprehension of the real-world problems, if the stakeholders think it's possible, your computer will think it's possible. And that's what domain-driven design promises you. So, we're actually wrapping up fairly ahead of schedule, which is nice because there'll be time for questions. So, communication. What have we learned? It helps to reuse context where possible. It means that we can all play the same language game, including our stakeholders. It means that we can communicate more easily with our team members and with the people outside of our team who determine what work we need to be doing. It means we don't have to spend effort translating between what the real-world problem is and what our computer thinks the real-world problem is. It means that our signifiers can match our concepts more closely, and so we can have a better chance of getting to a stage where what's in my head is something similar to what's in your head, and we can all get paid. So, conclusions. Computers are awesome. Talking to them is different than talking to people because they don't have interiority, and we can know that we are correct and that we are communicating adequately. I think this is why so many of us who might have had problems communicating as young people, I know I certainly did, were drawn to computing because it's a way that you can say, I want this to happen, and then it happens in a way that you can never do with another person. Communication is hard. It's intrinsically impossible to know if I have correctly communicated, adequately communicated a concept to you. I don't know if I succeeded today over the last 30 minutes, but we can get better at it by understanding mechanically what is going on when we have ideas in our head, say words or make gestures to try and communicate them, and hope that they cause an idea in the heads of the people that we're speaking to. And if we get better at it, we can spend less effort at our jobs, have easier times in relationships of all kinds, and have more time to play Baldur's Gate 3. Thank you very much. That QR code will take you to a little form where you can give me feedback if you so choose. There is, of course, also Slido. We have about 10 minutes for questions, or you can go and get a head start on lunch. Thank you so much.
Eli Holderness, everybody. I have to say, first off, your pronunciation of Machka, spot on. And that leads us to our first question. Are you talking, as you were talking about languages, what do you think about Hungarian?
My grandfather was Hungarian. I know a little bit. And honestly, I mostly talk to my cat in Hungarian. That's how I practice. Oh, eno jó macskám, oh, yeah. Yeah, I love Hungarian, not an Indo-European language, super cool. The Duolingo owl is going to break my knees, though, because I haven't looked at it in a long time.
Thank you. Turning from cats to humans,
Yep.
are computers better than humans?
Define better. What do you mean by better?
That's a question for
Better
Anonymous.
at certain things, certainly. A computer can do maths much faster than I can. I think if you want a really interesting exploration of this idea, Ashi's talk yesterday, Agency, was a beautiful exploration of the kind of, not consciousness, but the ways that LLMs operate and the ways in which they're different, their cognition is different from humans. I would say no, computers are tools. And I don't know what it means to be better than a human, because we're not, by what metric, you know?
Very nice. We have one more question.
It depends.
And time for more questions, so please use Slido to get those in there. Do you think in the future we will become a computer plus human brain where we don't have problems on communication?
I don't think we will ever not have problems of communication because we have interiority. You know that sort of philosophical chestnut where you go, is the blue that you see the same blue that I see? I don't know if we'll ever be able to overcome that. Because even if you say, okay, well, I'll have a chip in my brain that communicates with a chip in your brain, the way that my brain uses electricity in order to cause thoughts to form and chemical signals to be sent around my brain might be completely different than yours. We don't actually, I mean, I'm not a neuroscientist, and we have some, you know, we can do MRIs to understand like what's going on in the brain, but we don't have that level of understanding of the relationship between physicality and thought and what consciousness even is. So I think there is an intrinsic, dictionary word, ontological barrier to communication ever not being a problem anymore. As to whether or not we'll ever become computer-human hybrids, I think we already are. Like, my smartphone is practically a part of me, right? Might not be physically integrated with my body, but I think of it as an extension of myself. If I don't have it, I feel incomplete. And of course, we already have the situation where lots of humans are living with digital augmentations to their lives, either as an aid to assist in a disability or for other reasons. Computers are here to stay. I think we're all more hybrids than we know, but I don't think that the problem of communication is ever going away. I think that's part of what it is to be a person.
How can we sell the idea of building a shared language to shareholders? In my experience, Anonymous, the concept is foreign to people most of the time.
I don't know if I would phrase it like that when I was going to shareholders. I mean, this is the concept of like ubiquitous language from domain-driven design. I think the onus of building that language is on the development team, unfortunately, because unless you want to sit them down and make them watch my talk. How do you sell that value? I mean, you could explain to them, like, the better we understand what it is you mean by these things, the better we will be able to build software that acts on those concepts and according to those rules. Whether or not that is enough to convince them to put in effort, it depends also how much effort it will take from them. So, for example, my background over the last couple of years is in developer advocacy and developer experience. A lot of the stakeholders that I'm talking to, users, for example, are also developers. So we already have a lot of shared context, shared language. They understand what's meant by, oh, actually, you know, the server is doing this and this is the response we're getting. It depends how much of a gulf there is between you and those stakeholders, how divorced they are from your reality and vice versa. The bigger that gulf is, the more effort will be needed to bridge it and the harder you'll have to work to sell this idea. But similarly, the bigger the benefits will be. I don't have direct experience of doing this kind of negotiation. I think this is definitely something to ask people who've been practitioners of DDD for a long time, because they'll have direct hands-on experience of negotiating these kind of conversations. Glib, short answer, show them my talk, I guess.
Thank you. We have one more question here. What is your opinion on LLMs unlocking this next level of high thought-put of human language to computer logic communication?
So my understanding of LLMs is that they are essentially very, very sophisticated statistics. They are looking at a massive, massive corpus of human language, natural language, and building a model of what language looks like as a result of being able to parse this and do sort of things like, again, Ashi's talk I would highly recommend from yesterday, being able to associate tokens with some kind of meaning based on how often they see those tokens together and so on. LLMs don't have a concept of truth. They don't understand, like, more people have been to Berlin than I have, is a good example of this, where obviously like LLMs have a better grasp of language than to output something like that, but the concept still remains is that if something looks like it could be true, good language, there's no reason an LLM shouldn't output that, even if it isn't meaningful, right? So I think that there are hurdles we have to overcome before they're much more useful than programming languages already are in terms of using human natural language to communicate with computers. Because with prompt engineering, the thing I always think is, you've got these very specific ways to make the computer do what you want, to make the AI do what you want. We already have very precise, specific language for telling a computer to do what you want. It's code. So I think prompt engineering is eventually going to become something very similar to simply writing code. I think where LLMs are going to see the most usage are in situations where their output is easily checked for truth conditions, like code. Does it compile? Does it pass tests? Where the domain is very constrained and ideas of truth are not so nebulous. I don't know. I'll be interested to see where it goes, I think is my answer. But I'm not particularly bullish on the idea that it's about to send us into a new era. I think it's a new tool with a lot of potential for good and bad.
Thank you so much. We have some gifts for you as a speaker. And the thing I think will live rent-free in our brains, all of our brains, is that it's time to unsharpen the baby. So,
that's always the takeaway. It's the best slide.
Thank you so much. Eli Holderness, everybody.
Thank you so much for your time and attention.
Thank you.